At first glance, law of cosines can seem very intimidating. Yes, there are 3 versions, but you notice this basically just has little a here by itself. This one has little b by itself. That one has little c by itself. And then you notice here, if a is out here, look what angle is at the end. If little b is out here, look at what angle is at the end. And if little c is right here, oh, look at that. Look at what angle is at the end. And seeing this as law of cosines, are you too surprised that there's a cosine in the problem? I'm hoping you're not. Just like law of sines had all sines in it. And then notice, if a is out here out front, notice b and c dominate the rest of the problem. If b is here, the other 2 sides, a and c, dominate the problem. Because let's face it, isn't this kind of the setup we had? A is here and little a, right? B, little b, c, little c. That's the pairings we were using, right? And so the pattern really isn't that hard. And in fact, I'm hoping once you write it a couple times, you'll kind of have it figured out. Does this portion of it look familiar? What does that look like? Pythagorean theorem, isn't it? That looks very familiar, and it is. It is Pythagorean theorem. And what I've told people in the past is we know Pythagorean theorem only works for a right triangle, right? So that minus 2b cosine of a is just in case it's not a right triangle. That takes care of the problem. Look at it that way. That's the problem solver over there. That some people say, so does it kind of turn it into a right triangle? I'm like, well, not really, but if you want to think of it that way, that's fine. If that's going to help you remember it, that's fine. But that's not exactly what it does. But it basically allows you to solve it. That's the error, I guess, in the problem, you could say. So why don't we just use this and see what we can come up with. So we've got angle A is 35. All right, well, let's put this in there. I think I gave you the pictures, right? You have them? Yeah? Okay. And it says that side B is 16. So can I put 16 wherever I want, or is there a very specific place I've got to go with that? Yeah, I see a lot of you kind of doing the diagonal there. Yeah, so little b is over here because angle B is right there, and you have to go opposite. And then side C, again, very specific, has to go there. Now, if I saw a pair right now, I would suggest using law of sines, because let's face it, that formula is a lot smaller, right? Well, I don't see one. And I hope you agree that law of sines is a much shorter formula, because what we're going to do is we're going to try and set that up. And to get a pair, let's face it, don't I need that? If I could get little a, we'd have a pair. And then we could solve the rest with law of sines. Well, based on that, if I want little a, of these 3, we'll call this number 1, number 2, and number 3. Well, which one kind of has little a as much by itself as we can get it? The first one, right, has little a almost all by itself. With one small difference, there's a square on it, right? But can our calculators take care of squares? We know how to do that, right? So let's do that one. So yes, we are going to use that one. So let's fill it in as best we can. Do we know what a is? No, that's the problem, that we don't know what a is. Do we know what little b is? Yeah, little b is, well, 16. Plus little c is 19. Minus 2 times b is what again? Is 16. You notice on the inside, are we worrying about a at all? Obviously not, because we don't know it. That's why it's not on the inside. If we don't know it, how is having it in here going to help? All right, times, what should I write next if we're following the formula? It says 2 times b times c, which in this case is 19, and then cosine of angle A, which is 35. So did that basically use all the information we had to help us find the side? It did. Now the beautiful thing about the TI-83s, or even the TI-30X2Ss, I don't know why that has to be such a long name, but is you can type that straight in. You notice where I put the parentheses though. That's why I put them in there, to show you how to type that in. So what I'm going to do is I'm going to write it over on this board so I can still see it. And then I'm going to go to the calculator to show you how to type that in. But what is one thing I haven't checked yet, though? I told you to check it, but I haven't checked on my calculator yet. That it's in degrees. Again, yeah, I told you, but I haven't checked yet. Does anyone remember how to do it on these? Where do you check on these? Yeah, hit mode. And am I in degrees? Yeah, we're good. So let's get out of there. All right, so what do we got to do? 16 squared. Here we go, 16 squared. Plus 19 squared. Now the minus, does it matter which one do you hit? Can I hit this white one down here that's a negative looking sign, or do I have to hit the gray one that's minus? Yeah, hit the gray one that's minus. Very good. Minus 2. And if I were you, I would do this. Put the parentheses in. Did I type times in there or no? No, you don't have to. It knows. And then parentheses, 19. And then cosine. Did I hit times that time? No, it just knows. And then 35. And you're probably getting pretty good at these calculators. Does this final parenthesis make a huge difference as I'm typing right now? No, but again, I want you to get in that habit, because let's face it, sometimes it is important, sometimes it's not. So let's just get in the habit of always closing them off. That way you're not like, well, do I put it? Do I not put it? Because like, look, around the 16, we opened it and closed it. Around the 19, we opened it and closed it. So let's just get in that habit. Because if on any of those, they could cause some problems in later problems. So if I hit enter right now, is that what A is? That's what A squared is. Very good. But again, I showed you that trick the other day, how we can use this calculator to save us time. So if I hit enter right now, you're telling me it's going to be close to the answer, but not quite the answer. So that right there is A squared. Do you agree with me there? That's not what A is. So what do I have to do to that number right there to just get A? Square root. Okay? Because if A squared equals that, let's take the square root. Now where's the square root here? Here it is. So second, enter. Now who remembers how to get that number down into that spot? Can you? Yeah, the ANS button, answer. Again, you could type that in if you want. It's right there. Or for on the TI-83s, but if you're on the TI-30s, well, you might want to just bring up answer then. So second, answer. So it's going to take the square root of that number for me. Apparently it's 10.9. Does that fit in with the rest of the numbers we had on the triangle? Does 119.95 fit in with the rest of the numbers we had on that triangle? No. So at that point, you should have known that wasn't A, that was A squared. Right? So, and let's do sides to the nearest tenth, and we'll do angles to the nearest degree or something for today. Make sure you check the directions on your assignment. I think they're similar, though. So where are we at here? So 10.9 is A. Any questions how we got to that 10.9? Well, if you're having troubles with your calculators, you might want to have me come around and take a look. Okay. Now this does say to solve the triangle. Has the triangle been solved? No. Well, that's not good. Well, I'm going to tell you something right now. This very important bit right down here. I've kind of mentioned it to you before. Whoops. Helps if you get rid of the marker, though. Once you get to law of sines, and we are at law of sines right now because do I have a pair? Yes, I do. Calculate the smallest remaining angle first. Remember I told you that when we did law of sines? I was prepping you for that. I'll be honest, in here I try and stay away from the problems that would cause issues for you. But there are some that you gotta kind of be careful with. So which one do you think is going to be smaller, angle B or angle C? Angle B should be smaller, right? Because it's got a smaller side across from it. And so what we're going to do now is set up law of sines. So sine of 35 over 10.9 equals, and if we're going for B, it'd be sine of B over 16. And why don't you take a second and try and solve that? All right, let's see how you did. Well, for law of sines, now we have to solve this. We take 16 times the sine of 35, and it equals 10.9 times the sine of, well, it almost looks like a 13, doesn't it? Sine of B. Is this one of those where the variable's kind of embedded quite a bit? It takes a little bit of work to get it out? Yeah, this one takes a little bit of work, doesn't it? But good thing we learned this already. So what should be my next step? Try and get B by itself. Well, the 10.9 is kind of in the way, isn't it? So how do you get rid of that? Divide by it. And can your calculator handle that calculation right there? 16 sine of 35 over 10.9. Can your calculator do that? Yeah, it can figure that out for you. Sine of 35 over 10.9. Again, I'm just writing it on the other board so that when I go to my calculator, I'll be able to type that in. Everybody ready? So let's get rid of all that stuff. So we got 16 sine 35. Wow, apparently it helps if you hit sine though. parentheses this time, important, not important? Yeah, big time important, right? But again, if you just do it all the time, then you should be fine. And then divided by 10.9. So this is supposed to give me the angle? Is that what this is supposed to do? So hit enter. Well, that's a very strange angle. How's that work? Oh, that sine of B is that. Oh, so sine of B equals 0.8419. That was just me trying all the different markers until it actually worked. All right. So sine of B equals that. Well, how am I going to deal with it? You got to get sine out of there, which means take, what's it called? Arc sine. Very good. But if you take arc sine over here, it cancels, so you got to take arc sine of that. Is that also something the calculator can handle? Yeah, and I showed you that little trick so that you don't have to write down these decimals that whole time. So let's take arc sine of, and how do we bring it up again? Oh, that answer. That's right. So the answer. So now when I hit enter, will it give me the angle? Yep, and if I'm in degree mode, it'll give me the angle in degrees, and that's what we want. Is that a believable angle? Yeah, I'd say with the rest of the numbers we've got, that's believable, right? 57.3, or did I say nearest degree, or what do I want to do here? Yeah, let's do 57.3 is fine. So we write that down. Whoops, that's not you. So where does that go? Does that go for angle C? Oh, angle B, 57.3. If I wanted to, could I use law of cosines to find angle C? I could. If I wanted to, could I use law of sines to find angle C? I could. Should you? No. Because let's face it, we got 35 degrees, we've got 57.3 degrees. It should be pretty straightforward to just get that other angle by using 180 degrees total. And on mine it says 87.7. Does that also fit in with the rest of the numbers? Yeah, biggest side, biggest angle, smallest, smallest, all fits in. But what we didn't have at the beginning was a pair. We had to go get one. And once we did that, it kind of fell apart pretty quick. Okay. Any questions on law of cosines, law of sines, or calculator issues? Because I think some of those, you got to kind of type things in backwards, and they are kind of difficult. So if you got one of those, maybe get one that you can type it in and see it on your screen. They're a lot easier to work with. Okay?